M1 May 2012 Question 2. Part 1. Draw a force diagram showing all the forces acting on the car. We will have a reaction force, normal reaction, which is always perpendicular to the plane, the weight of the car acting down, which is its mass, 1300 kilograms multiplied by g for gravity, the traction force, pulling the car up the slope at 1200, and the resistance to motion, friction, acting against the direction of motion, so it's going down the hill. This is your solution to part 1, so I would encourage you to draw a second diagram on which you can show your resolved forces for all working in part 2. To answer part 2 and find the acceleration, I'm going to start by redrawing my force diagram, and this time I am going to resolve the components of the weight. So I'm going to start by adding all the forces. Then I'm going to add the weight, which will have 1300 G cos 20 acting into the plane and 1300 G sin 20 acting down the slope. Perpendicular to the slope, the forces are in equilibrium, so the normal reaction R has to equal 1300 G cos 20. And I also know that friction equals mu R, and friction in the question is 0.25, multiplied by the 1300 G cos 20 gives me 2992.920. At this stage you should not round. Now that we know what the normal reaction and friction are, we're going to consider parallel to the plane. And if I consider parallel, I'm using Newton's second law. Resultant force in the direction of motion, so that's 12,000 minus friction minus 1300 G sin 20 has to equal mass times acceleration. I now need to substitute in my value for friction, which gives me 4,649.74 has to equal 1300 A, which gives me a value for the acceleration of 3.576, and if I round that to three significant figures, that's 3.58 meters per second squared.